Look at section 4.1, triangles and congruent figures. Let's start out with some definitions. These are types of triangles. An acute triangle, an adorable triangle. It's a triangle with all acute angles. Let's draw a picture of that. Here's an example of an acute triangle. What makes an angle acute? Well, an acute angle has to be larger than 0 and it has to be less than 90. An acute angle is larger than 0 and less than 90 degrees. So since all the angles in this picture are between 0 and 90, it makes it an acute triangle. An obtuse triangle is a triangle with one obtuse angle. It's impossible to have more than one obtuse angle in a triangle. Here's an example of an obtuse triangle. What's an obtuse angle? An obtuse angle is less than 180 degrees but bigger than 90. So it's between 90 and 180. A right triangle is a triangle with one right angle. A right angle means 90 degrees. And the symbol for 90 degrees, you can write 90 or you can put this little square in here. In a right triangle, the sides of the triangle have special names. The sides that make up the 90-degree angle are called legs. So here is leg 1. Here's leg 2. The side opposite of the 90-degree angle is called the hypotenuse. And I think I spelled that correctly. So these are 3 ways to categorize triangles by their angles. This is angle categorization. There's 3 ways to categorize triangles by their sides: scalene, isosceles, and equilateral. Scalene, a triangle with all sides different lengths. To show that they're different lengths, I'm going to put the same number of dashes on each of the sides. Triangle ABC is scalene. Each side is a different length than the other sides. Isosceles. This is a often misinterpreted definition. It's a triangle with at least 2 sides congruent. So if the 3 sides are congruent, it's still isosceles. So here's a triangle with at least 2 sides congruent. There are special names in an isosceles triangle. The 2 sides are the same length are called legs. So there's a leg 1 and here's a leg 2. The side that is, if an isosceles triangle has 2 sides the same length and the 3rd side is a different length, that side is called the base. Each of these angles here, where the base and the legs come together, those are called base angles. There are 2 of those, that's why I have a subscript 1 and 2. Where the 2 legs come together, that's called a vertex angle. All things you have to know. Equilateral triangle. A triangle with all sides congruent. So this is a special type of isosceles in which every side has the same length. It's an equilateral. Equal means same, lateral means sides. Sides are the same length. It gets us to some theorems. The isosceles triangle theorem. If 2 sides of a triangle are congruent, then the base angles are congruent. Showing you this with pictures. If the hypothesis here is essentially saying you have an isosceles triangle. So here's triangle Fox. Notice that side FO and so side OX are congruent. The conclusion that we can draw from this is that these base angles have to also be congruent. That's the Isosceles triangle theorem. If two sides of a triangle are the same length, then the base angles have to be the same as well. The converse to the Isosceles triangle theorem takes the hypothesis and conclusion in the original theorem and reverses them. If two angles of a triangle are congruent, then the sides opposite those angles are the same. Oops, I got sides twice. That's ridiculous. So in pictures, if we have this triangle, Fox, and we're told that angles X and F are congruent, the conclusion that we can make from this is that the sides opposite those angles have to be congruent. The Isosceles triangle theorem and the converse to the Isosceles triangle theorem, essentially, the end result is it's the same. But the difference is, in the Isosceles triangle theorem, you know the sides are congruent. You make a conclusion that the angles are. For the converse, you know the angles are congruent. You're concluding that the sides, then, two of the sides are the same length. Let's check out some examples. There's no directions for this. Let's assume that there were directions, and let's assume that directions said, find the value of x. Or according to the Isosceles triangle theorem, since this side and this side are the same length, these base angles have to be the same. So if this base angle is x, then this one has to also be x. And then using the angle sum theorem, all the angles in a triangle sum to 180 degrees. If we combine like terms, x and x is 2x. We could subtract 48 from both sides of the equation. I think that would give us 132. And then if we divide both sides by 2 to get x by itself, I believe we're going to get x is 66 degrees. So if each of these were 66, and we add that to 48, we would get 180. Another example. I forgot what numbers I'm supposed to use for this. Please pause for station identification. We're back. Let's say that this side was 2x plus 3, and this was 4x minus 7. Assuming the directions existed, and in your homework and tests and quizzes there will be directions, let's say the direction said find the value of x. Well, since this side and this side are the same, that means they're congruent. Definition of congruent, it means that their measures are equal. So we can say that 2x plus 3 equals 4x minus 7. Then, to get x by itself, we could subtract 2x from both sides of the equation to get those like terms together. Then, we could add 7 to both sides to get those like terms together. Lastly, we could divide both sides by 2 to get x by itself, and we get x is 5. Next example, let's say that this angle was 40 degrees. And this one was x squared plus 3x. And let's assume there were directions, and the direction said, find the value of x. Well, according to the Isosceles triangle theorem, since these two sides are the same length, the base angles have to be the same. That's the Isosceles triangle theorem. Therefore, x squared plus 3x equals 40. Are you scared? Well, you should be. Here's why you should be scared. We have an equation in which the variable x has an exponent of 2 here and a 1 here. How do we solve such a thing, you may be asking yourself? We have to get all the terms on the same side of the equation and then factor. In my experience, most students are not very good with factoring. This is a trinomial. There are 3 terms. If you're lucky enough that the lead coefficient is a 1, and it is, because no number was written in front of x squared, this is the easy type of factoring. You're going to make 2 binomials. Binomial means you're going to have 2 terms in each of these. There are 2 of them, so we have 2 binomials. Right now I'm using empty parentheses because I don't know what's going to go inside of them. In the first position of each of these binomials, you're going to take the square root of this first term, x squared. Square root of x squared is x. That goes in the first position. Then, to figure out what goes in the other spots, you have to do a little bit of work. But if you can do this in your head, I'm cool with it. You don't have to show the work that's in black. But if you can't do it in your head, maybe you want to write this stuff down to give yourself a process. We need 2 numbers that multiply to get negative 40 and add to get positive 3. Getting negative 40 from this, I'm getting positive 3 from the middle term. Once again, if the lead coefficient is not 1, there's a longer, more tedious process, but we lucked out and it is 1. So 2 things that multiply to get negative 40 and add to get 3. Let's say you're terrible at this. Well, negative 1 times 40 is negative 40. Does not have to be 3. Negative 2 and 20 multiplies to be negative 40. Doesn't add to be 3. Negative 3. So I want negative 1, negative 2. Negative 3 does not go in the negative 40. I don't use it. Negative 4 does. 10 times. That adds up to be 6. That doesn't work. 5 goes into it. 8 times. Hey, looky what we got here. Negative 5 times 8 is negative 40. Negative 5 plus 8, positive 3. So in one set of parentheses, I'm going to put the minus 5. In the other one, I'm going to put the plus 8. Doesn't matter which one you put where, as long as you have the minus with the 5 and the plus with the 8. Once it's factored, you set each factor equal to 0. And you solve each of those little equations. You're going to get x equals 5 and x equals negative 8. Sometimes you get some wrong answers when you do this, answers that don't make sense in the context of the problem. Let's just check mentally. If we put a 5 into this, we get 5 squared, which is 25, and then 3 times 5 is 15. 25 and 15 is 40, so that works. Let's try this other one. A negative 8 squared is 64. 3 times negative 8 is negative 24. Subtract those, you're also going to get 40, so they both work. So our solution for this is x equals 5 and negative 8. Hey, more theorems. Awesome. Equilateral triangle theorem. If a triangle is equilateral, then it is also equiangular. Equiangular means all the angles are the same. So let's say that we have this triangle, triangle N, and we know that the sides are the same length, because that's the hypothesis a triangle is equilateral. The conclusion we can make from this is that each of these angles have to be the same. A side note, if they're all the same and they add up to be 180, they have to always be 60 degrees. Converse to the equilateral triangle theorem. Converse is when you switch the hypothesis and the conclusion. So if the triangle was equiangular, then, you know what, this previous one, I left out some words, then it is equiangular. Here, if the triangle is equiangular, then it is equilateral. So let's say that we have a triangle and we know that it's equiangular, like so. The conclusion that we can make from that, according to the converse to the equilateral triangle theorem, is that the sides all have to be the same length. It's equilateral. Moving forward, congruent figures. Congruent figures are two shapes that are the exact same size and the exact same shape. More formally, congruent figures are two figures with corresponding sides and angles congruent. Two figures with corresponding sides and angles congruent. Well, what are corresponding parts? Corresponding parts, whenever that's referenced, it means that in the case of polygons, which is what we're talking about, and specifically we're talking about triangles right now, corresponding parts would be sides and angles. That are paired together. Show some examples of this, and hopefully it'll make more sense than those words that I just used. Example 1, it says list the congruent parts. We're told that triangle EFG is congruent to triangle ZXY. The order of the letters matter. So E is first. Let's see if I can make that smaller. That corresponds to Z because they're both the first positions. F is second. That corresponds to X. They're both in the second positions. G is third. That corresponds to Y. They're in the third positions. If you don't have anything to color with, you can do something like this to show which parts correspond to each other. So in our picture, angle E, let's say it's one arc, has to be the same number of arcs as Z. They're congruent. Congruent has the same number of arcs in our picture. F and X go together because they're both in the second positions. And G and Y go together because they're both in the third positions. This is also true about the segments. The first segment here is EF. It's congruent to segment ZX. Notice also that the one arc is between, the one dash is between one arc and two arc. This one dash here is between the one arc and two arc. So we could look at this continuing between the two arcs and three arcs. Let's say that that's three dashes. Between the two arcs and the three arcs, that's three dashes. And then between the one and the two arcs could be two dashes. So the pictures are not drawn the same orientation, but since you're told at the beginning how things match up together, you know which parts go together. So looking at the picture or the congruent statement, we could say that angle E is congruent to angle Z, angle F is congruent to angle X, angle G is congruent to angle Y. Take a moment and look at those and make sure you understand why. We could also say segment EF is congruent to segment ZX. I sound French when I say ZX. Mon chéri. Segment FG is congruent to segment XY. And segment GE is congruent to segment YZ. That last one's a little strange if you're looking at the congruent statement, because I went EF is congruent to ZX, that's the first thing I did. Then I went segment FG is congruent to segment XY. Then for the last one I have to go GE because it kind of wraps around here. And then it's going to be YZ because it wraps around here. Example 1 said list the congruent parts. We listed there are always going to be 6 pairs of congruent parts in triangles, 3 angles and 3 sides. Example 2, identify the congruent triangles. So here the picture shows which parts are congruent, but we don't know how to write the congruent statement. Here's what I would do. I'd focus on the angles. I'm going to look at triangle RQS. I'm going to go 1 arc, 2 arc, 3 arc. So I'm going to write that down from the 1 arc to the 2 arc to the 3 arc. You don't have to go in that order. You can go in any order you want. But when you pick the second triangle, you got to go in the same order. For me to go to 1 to 2 to 3 arcs, I'm going to have to go B, C to D. Now, if someone else had made their first congruent statement as triangle QRS, that went from 2 to 1 to 3, that's fine. But you'd have to go 2 to 1 to 3 on this other triangle. That'd be triangle CBD. Notice no matter which one you pick, R and B are in the same spots. Q and C are in the same spots. S and D are in the same spots. That's what matters. Almost finished. All right, we got 3 more problems. This says that we're supposed to figure out what is SR congruent to. You can easily do this just by looking at the congruent statement up here. S and R are the outside letters, so it's going to be congruent to G and T, that segment. Another way to do it, take everything that you're told in the congruent statement for the triangles and put it in your picture. Angle R and angle T are congruent. So angle R in this top triangle, TGR is this bottom triangle. So R and T are congruent. Angle T in the top triangle is congruent to angle R in the bottom triangle. And then S and G go together. And then that makes TR the same as itself, obviously. That is like being your own grandpa, quite frankly. It's a reflexive property. SR is between 1 and 3 arcs. TG is between 1 and 3 arcs. RG could be 3 dashes. It's between 2 and 3 arcs. ST is between 3 and 2 arcs. You don't have to do all that to answer the question. You just got to do this. And that can be done by looking directly at the original statement, as can be noted in the second example. Segment YZ is congruent to which of the sides? Once again, YZ are the outside letters. So segment JZ is going to be congruent to it. By the way, these little marks I'm making up here, those aren't special marks. I'm just identifying which letters that we're talking about. Last one. So we got angle MNL, MNL. That's going to be congruent to HNI. Just naming them in the same order. MNL is going to be congruent to HNI. Just going to show you how this relates to the picture. This is not work you would have to do for this particular problem, but if you're asked to find measures of things, you'd want to do this work. So in this first triangle, this is the blue triangle, and let's say this is the red triangle. L corresponds to I, so they have to be congruent. M corresponds to H, so they have to be congruent. And then N in the first triangle corresponds to N in the second triangle. So you can see the pictures are not drawn with the same orientation once again, which makes, I guess the orientation's the same, they're just rotated. Makes it confusing. But if you focus on the congruent statement, then you're going to be all right. Please do your homework, which is section 4.1, and have a great day.